So in the last video I said that we would begin exponents, but there's a couple things missing before we do that. So I was jumping ahead of the curve, but we learned addition. We saw a bit of subtraction. But what's missing is the multiplication and division. These are the four operations we need to concern ourselves with, because then that's going to lead us to order of operations, which should be the next lesson. I don't want to overwhelm you too much. Order of. And once we learn that, then we'll be getting close to the exponents. But right now, we need to learn how to do the multiplication and the division as well. So let's start off with the multiplication, okay? So again, let me clear this for you. So again, what we need to, So again, we're going to use the variables, right? So x times 3 is equal to 6. And I mentioned trial and error. So we can always do 1 times 3, 2 times 3, 3 times 3, right? 3, 6, 9. And then through trial and error, you would find that this is your answer. But again, as I showed you in the first lecture, we don't have time for that, right? Because you could have this. Divided by 4.5. Z squared equals 8. You don't have time to do trial and error. That's just going to be painful. So again, there's a process and method of doing this, right? And so and you've noticed how I put these together, put these in brackets. So this is another way. So instead of saying x times 3, we could, or 3 times x equals 6. There are other ways of writing these, because again, as you can see, it gets a bit confusing where you have a multiplication symbol and you have variables. So in order to avoid that, what's been done is a lot of the times you'll see this. And it's a much cleaner way to show what you're trying to do. So 3, right? Very, very clean. And sometimes you'll see them saying, well, I want to group these together so, it doesn't look that confusing as well. And then this can also have actually a different meaning, right? Compared to 3xy. I'm getting a little ahead of myself. So this, right, is the same as saying, well, let's take 3 and multiply it by x, and let's take 3 and multiply it by y. Right, so different meanings on how you're going to group them. But the key to the matter is we're trying to simplify how we show these multiplications. So again, let's go back to this. Let's now use a new notation. So rather than saying 3 times x equals 6, right, we're going to say 3x equals 6. So how do we get this answer? Well, in order to get this answer, we need to know the operations, right? So the opposite of multiplication is division. So we're going to do a little bit of division to get that. So we divide by 3, right? And this is very similar to what you're seeing with the addition and subtraction. What we do to one side, we do to the other side to maintain the balance. So now we have x equal to 2. Well, how do we know if that's correct? Well, let's just say 3 times 2. Well, that equals 6, so 6 equals 6, so that checks out. So now we've shown you how to get the variable by doing the opposite of multiplication, which is division. Well, what if we did this? X over 4 is equal to 8. Well, the opposite of division is multiplication. Well, let's say multiply. So let's try doing to one side what we do to the other side, right? So 4, 4. So this cancels out. 4 over 4 is 1. So now you have x is equal to 32. Well, is that correct? Well, 32 over 4. So how many 4s go into 32? Well, that's 8 times. So 8 is equal to 8. So that checks out. So you can kind of see the beauty of how you can check your work, right? So it's very, I don't want to say very circular, but there's an ebb and flow to this. So if you divide, you should be able to get the reverse answer when you multiply. So let's take this to another level. And I said x over 4. Well, what if I say 4 over x is equal to 8? Well, what do I do here? Well, I can multiply both sides by x, right? So now it's 4 is equal to 8x, and then it's the simplest thing, right? So now you have 1/2 is equal to x, right? So does that check out? Well, here we had 8x, right? So let's move this here and say 8 times 1/2 equals 4. So when I divide, I get 4 equals 4. So that checks out. So we've done this with simple examples, right? Just me giving you 4x equals 8, 4 over x equals 8, or x over 4 equals 8. But what if I made this a little bit more complicated? What if I just said, well, what is it, 4x plus 3 equals 8? Well, hold on, let me do this in my head. No, it's fine. We're dealing with fractions. We can handle it. So, how would I do this? There are a couple of ways to do it, but what I'm seeing here is if I can subtract 3 equals, and if I could subtract 3, I can isolate this 4x, right? Get 5, and then if I divide 4 by 4 by 4, right, I get x is equal to 5 over 4. But then if I want to simplify it, I can also say 1 and 1/4. So, depending on how you want to see the answer, this may be more favorable or this may be more favorable. But you can see how you can start to add different variations and permutations, right? And you can even, like I said, take it to another level. 4 plus y equals 8z, right? You could take it to another level to solve this. And sometimes you may just get variables as an answer, right? So your teacher or somebody might say solve for x, or better yet, solve for y. So depending on how you want to solve, you can, if we solve for y, right, then that's just as simple as saying y equals, and a lot of times you'll see people simplify it as, okay, let me quickly do this. Oh, some people might say, well, these have common factors. So then you'll see some people say, well, this is 4 equals 2z minus minus x, right? And so you can see how you could get really intricate with the the basics of algebra, and we haven't even gone that far yet. We haven't include the exponents, the system of equations, and so forth. So I hope this gives you an idea of the beauty and intricacies of this. And the next we're going to do is order of operations in the next lesson.